Hi everyone. So today we will solve this problem equal row and column pairs. So our input is a matrix and the size is n by n, and we have to return the number of pairs Ricj such that Ri and Cj are row and column respectively in the given matrix. So what does this mean? So if we have a matrix like this, in this matrix we have some rows and column. So this is row 1, this is row 2, this is row 3, this is column 1, this is column 2, this is column 3. So we have to return such pairs where this particular row, like any one of the row, is equal to any one of the column. So how we check if both the rows and column are equal or not? We will match their corresponding elements, right? So let's look at this example. Here if we see, for row number 3, we have elements 2, 7, 7. Does there exist any column where we have value 277? Yes, there exists one column which is this 277, right? So if we see, corresponding elements are equal. That means R3 and C2. This is one of the pair, row 3 and second column. So that's why we have output as 1, because now there does not exist any other row column pair. So let's look at the solution for this problem. So this is our input matrix. The size is 4 by 4. And the simple strategy to solve this problem is using map. So what we will do, we will store all the rows of this particular matrix in map, right? So let's represent these rows as R1. This whole row from here till here, it is represented by R1. Similarly, second row R2, third row R3, then the fourth row R4, right? So in the map, how this will be stored? We have this map. Here we will have row and here we will have the count. Like how many occurrences are there of this particular row? Because it might be possible that if first row has value 1, 2, 3, 4, second row might also have the same value. In that scenario, we have to count it 2 times, right? But in current case, that is not the scenario. So if we see, R1 has a frequency of 1, R2 has a frequency of 1, then R3, then R4 has a frequency of 1, 1 each, right? Now, once we have created this map, what we will do, we will again traverse the matrix, and now we will fetch or extract column out of this matrix. So we will first fetch this column C1. So if we see, C1 has value 1, 2, 3, 4. Is there exist any row in our map where this value is present? So we know this R1 basically represents value 1, 2, 3, 4. And here C1 represents the same value. That means there exists one of the pair. Okay. So yes, there is an entry for 1, 2, 3, 4 in this map. So this count we will include in our answer. Okay. Then this is the second column, 2, 3, 9, 10. Okay. If we notice closely, R2 also has the same value 2, 3, 9, 10. That means R2 will also form one pair. So we will include its count. Then the third column is 3, 9, 7, 12. Does there exist any row where we have the same values? No, it does not exist. So we will not do anything. Similarly, for the last column, we have 4, 10, 5, 32. And for this also, there does not exist any row. So for matching, whether there is a match or not, we will simply uh, look it into the map. Okay, we will not look into the matrix. We will directly look into the hash map which we created. So we extracted two ones from the map, so we can simply add them. So we have answer as 2. So there exists two pair, right? Which is R1 C1 and then R2 C2. All right. So this is it. So the only logic to solve this problem is to create a hash map of rows. Okay. And then we will extract column out of the matrix and we will check each column in the map if it exists or not. If it exists, that means there exists a pair, and we will simply add the count in our answer. Because suppose this is R1, it might exist two times in this matrix. So in that case, we will simply add 2 in our answer. Okay. So let's look at the code for this. All right, so this is the code. So simply, first of all, we will create a map. And if you notice, the first entry in the map is a vector. So this vector basically represents the row. And the second entry is the int. So this will store the count of that particular row in a given matrix. And this is our answer count. And first of all, we will count the frequency of each row. So what we are doing, if we notice closely, the input is a grid, okay, which is a vector of vectors. All right. So in this grid, how this matrix is stored, first vector will be, like if you look at this example, first vector will be 3, 2, 1. First row. The second vector will be 1, 7, 6. The third vector will be 2, 7, 7. This is how this grid will contain the matrix. So that's why we are simply traversing the grid, okay? And we are checking if the first element of the grid, what is the first element of the grid? It is the row first, 3, 2, 1. If it does not exist in this map, we will simply store 1 at that place. And if it exists, we will increment the count. So basically what we are doing, we are counting the frequency of each row in this grid. Once this is done, now we created a vector. Okay. This vector will store the value of column. So column is 3, 1, 2. All right. So now if we see what we are doing, we have two loops, two for loops over here instead of one like above, because we know in grid values are stored in the form of vector. Okay. That means first element will be 3 to 1 whole. But while extracting the column, we need values 3, 1, and 2. That's why we will have to traverse the whole grid. All right. So if you see here, what we are doing, we are storing the value in this call vector. After this loop, call will contain the first column, 3, 1, 2, and we will check if it is present in that particular map or not. If it is present, then we will include the frequency of that particular row in our answer. Otherwise, we will not. Okay. So after this loop, count will have all the number of pairs, right? So this is the code. I will share the link to this code. You can access it. And yeah, thanks for watching the video. Bye. Take care.